Welcome once again, bizarre creatures enthusiasts, as we embark on a meticulous, comprehensive biological investigation into the sophisticated biochemical warfare prevalent within the planet's most saline, specialized, and dynamically rich ecosystems. The tropical Indo-Pacific Ocean. Our subject today is the sea snake Hydrophini, a stunning, highly venomous elapid whose very existence in the dense, high-pressure, low-oxygen marine environment is predicated on extreme physiological adaptation and unparalleled venom potency. The sea snake presents an unparalleled masterclass in evolutionary lineage, employing a combination of flattened, paddle-like tails, specialized nasal valves, and the world's most neurotoxic venoms, cementing its status as one of the ocean's most feared, yet often misunderstood reptiles. The foundational element of their survival strategy is the alarming morphology of their fangs, which are not merely an injection tool but an intricately engineered sensory and delivery device, designed for maximum efficiency against small, slippery fish prey. Chemically speaking, the musculature controlling the venom glands allows extraordinary concentration and rapid manipulation, enabling the sea snake to perform a crucial predatory function, notably delivering a potent dose of neurotoxin to paralyze prey instantly. The critical level of defensive behavior. The sea snake exhibits a paradoxical effect by binding venom potency with physical constraint, using its specialized, small fangs, which are often too tiny and set too deep to penetrate human skin or dive suits effectively. This binding event is favorable for the specialized, often small fish prey because the animal is able to consume it without fatal consequence, completely overriding the prey's escape mechanism. The resulting continuous, rapid envenomation allows the sea snake to access mobile food resources that are too fast or inaccessible to almost all other major marine predators, causing persistent and forced exploitation of the water column niche. This overwhelming, highly focused hunting strategy rapidly leads to severe central nervous system disruption for the prey, resulting in immediate systemic paralysis, followed inevitably by catastrophic, unsynchronized ingestion by the specialized marine predator. The historical context of this morphology is critical. The paradoxical truth about the sea snake's inability to effectively bite humans remained largely unknown to the general public until modern toxicology, primarily due to its intense toxicity and the complex, inaccessible nature of its endemic habitat. Their method involves a deliberate, often non-lethal, yet highly efficient probing of the open water, allowing the precise collection of high-protein fish prey. A perfect example of sustained ecological utility through morphological innovation. The most profound biological enigma surrounds the animal's tail. Despite its visual distinctiveness, the tail is flattened into a specialized, paddle-like structure that propels it efficiently and prevents the catastrophic energy expenditure required for movement in the perpetually moving ocean environment. This specific anatomical specialization within their respiratory system essentially renders their entire physiological system tolerant to oxygen constraint, preventing the fatal energy expenditure that affects every other generalized terrestrial reptile. Crucially, the sea snake does not engage in extensive schooling. It operates purely as an ecological anchor, systematically utilizing micro-reservoirs of fish prey to fuel the massive metabolic demand of its specialized venom production. Focused, ecological research has definitively linked the sea snake's social structure to the prevalence of specific aggregation points, primarily marked by specialized pheromones in the water, which function as communication depots in the absence of complex sound cues. This highly specific trophic cascade implies that the ultimate venom precursors likely originate in the unique protein structures of the snake, are then synthesized by the venom glands, and finally concentrated by the fangs. A triple-layered ecological dependence. This highly specific behavioral structure implies that the ultimate reproductive signals likely originate in the unique hormonal composition of the females and are finally concentrated by the male during mating season. A triple-layered ecological dependence. The sea snake has evolved specialized, scale-like structures distributed across the entire body, which function exclusively as secure, permanent waterproofing depots for buoyancy and specialized protection against the nightly reef currents. The sea snake has evolved specialized, densely packed, neutral-colored scales distributed across the dorsal surface, which functions exclusively as secure, permanent camouflage and specialized protection against the nightly deep-sea darkness upon even minor mechanical stress or perceived threat. These animals instantaneously utilize their venom delivery system and specialized size for defense, creating a rapidly effective, ready-made sensory mantle that deters any potential intrusion attempt. This critical observation provides irrefutable evidence that the sea snake's powerful survival is an environmentally determined phenotype, inextricably linked to the unique, complex structural composition of the deep marine habitat. The loss of its specialized marine habitat and the introduction of plastic pollution and ocean warming presents a dire, dual existential threat. Not only is the animal losing its physical home, but it is simultaneously losing the entire biochemical support structure essential for its specialized reproduction mechanism. The incredible diversity across the Hydrophini genus shows a profound singularity. The sea snake's paradoxically small fangs are a unique evolutionary adaptation, a fact which reflects the precise, localized predatory specialization of this particular species. Beyond the aggressive venom production, the sea snake exhibits surprising degrees of obligate parental care, with the female vigilantly guarding her live-born young against desiccation and pathogenic fungal infection for weeks after the young are born. The dedicated mother undertakes the arduous, dangerous task of constant hunting, navigating the water column to locate isolated, predator-free micro-reservoirs of high-quality fish. In certain individuals, the animal exhibits an extraordinary level of aquatic adaptation, staying submerged for hours while it hunts, only returning briefly to the surface to breathe, a behavior known as diving. This high investment in offspring survival, contrasting with the animal's solitary, intimidating presence, beautifully illustrates the profound and often paradoxical evolutionary pressures at play in complex, high-mortality environments. The specialized venom system and fang morphology itself remains a cornerstone in modern toxicology, providing a perfectly calibrated, highly selective probe for studying the kinetics and structure of specialized drug delivery in human medical systems. By meticulously studying the venom composition and biochemical analysis, scientists aim to design specific antidote systems or novel synthetic tools that could revolutionize the detection of neurological disorders and anti-venom production. By meticulously studying the sea snake's specialized lung structure and oxygen absorption, scientists aim to design specialized diving gear or novel synthetic systems that could revolutionize human deep-sea exploration. The venom arsenal of the sea snake's glands collectively represents a vastly unexplored biochemical reservoir, holding untapped potential for developing new classes of biomimetic systems focusing on pain management and neurological blockade. The evolutionary phenomenon is further confirmed by the discovery of similar specialized venom composition in unrelated species, like certain cobras and krites, reinforcing the concept of a shared biochemical and ecological predatory strategy. Their unparalleled combination of extreme bizarreness, profound specialization, and specialized ecological dependence solidifies their status as one of the most enigmatic and scientifically crucial organisms on Earth. This intense scientific breakdown should leave no doubt that the most bizarre, visually shocking inhabitants of our planet frequently wield the most powerful, meticulously engineered, and deeply mysterious biological secrets. Now, we turn the focus back to you, our dedicated audience. Following this deep exploration, which other creature possessing extreme, bizarre, or unique skeletal or behavioral properties should bizarre creatures investigate next? Please share your suggestions for future topics, along with any specific questions you have regarding the sea snake's venom composition or its specialized lung capacity in the comments section below. We value your critical engagement. If you found this granular, scientific dissection of the sea snake and its ecology informative and stimulating to your curiosity, please take a moment to hit that like button to significantly support our specialized content production. Ensure you are permanently subscribed to the Bizarre Creatures channel today for continuous weekly updates and in-depth scientific narratives on the world's most incredible and often misunderstood animals. Critically, remember to activate the notification bell, guaranteeing that you are immediately alerted the moment our next exploration into the profound mysteries of the natural world is released. Thank you for joining us for this highly detailed session of Bizarre Creatures. Stay intensely curious, and we will continue the relentless pursuit of the world's most shocking biological truths together.